Hello everybody, I'm Herman Dolder and will explain our application. Uh, we try to keep it really simple so it does what it has to do. For example, when you open it, you only have this button enabled. It's load DM. You click it and you can select a DM, any of the kinds that are supported by GDAL, GoodAL, whatever. And when when it's open, now it enables it still lets you select another one if you don't like this one, or you can even draw a dam. So that's what we're going to do. First, we're going to zoom in a part that we think would be interesting to try. And when we click draw dam, two things happen. First, the cursor change into a cross that lets us draw, and then this bottom label change, because if you make a mistake, for instance, if I click here and I didn't intend it to do that, I could come here and just start again. So let's see, I want to try them from here to here. It's important that the way this algorithm works, it will start, you have to start digitizing from the left part of the dam into the right part. If you do it otherwise, instead of creating a dam, you would create something like a levee or a boulder or something like that. Well, then it ran, it found that this would be the zone that would be flooded, and it draw the line, this red line where we digitize the dam, and then it provides these two charts and this information. This is the area, the volume of water. This will be the cross section of the layout of the dam, and this will be an area that relates the height of the water with the area of the lake. Well, let's suppose that this is not what we want, so we can click in this button that was enabled. Now. It says reset, and let's zoom into another place. We have, for instance, this confluence, and let's see if we can get something here. You have to be careful because depending on the topography, you could probably connect two different basins and overflow this time into another one. Here you can say this part that says changes, that has these numbers changing all the time, and those numbers are the propagation algorithm that uses to calculate which cells will belong to the dam. So if that number grows really fast, then that means that you probably had overflowed into another dam. We could, well, again, we have the same results. We could probably try to do that just to show you what you would expect to see. So for instance, if I try to go too high with my dam, let's see, from here to here, and you see the numbers here, and then you saw a big number, and then are all those big numbers. Then when we see the result, we see that our dam will be overflowing into an adjacent basin, and that's because our algorithm selects the height of the water from the points that you digitized. Well, this would take a little longer, but I think it's interesting to see. So you can see that number sometimes gets higher and lower. If it has different branches, different streams, or that should be shown in that way, that the number would suddenly increase. And well, after a while, looking at that, you begin to understand what is happening. But this is really big. This is the number of cells. it's changing in each step of the propagation algorithm. So now it's changing like 500 cells in each step. So I guess we're going to flood the whole thing. Well, now it seems to begin to decrease somehow. Okay, there it grew again, and then, well, it's fun to look at. This DEM is pretty big, so if your computer is not that fast, you probably try to use DMs with lower resolution. So then it finished, and here we see what happened. Here's our dam, and here's the part that overflew. So instead of having, look at this. This is another point where our dam would overflow to the neighboring, and this is what we would produce if we do it this way. So this really makes no sense. But well, the last thing, we have this link that shows a help file. In this case, we're still working on the definite one, so we're just showing this text one. And well, finally, if you like the result, you can save this map as a TIFF, and you do that by clicking this button, Save. I wouldn't click it now because we're running a virtual machine and that would crash the program, but you can select the directory and you can save it as a TIFF file. So this is the way our application works. I hope you enjoy it.
Guys, this is Tony Melcher, and we are Team Dolder and Melcher. All right, I'm going to go through the code for our form. This isn't the actual algorithm. Erman will go through that code again, but our form and our algorithm actually communicate quite a bit. So we start off by defining our global variables, a few raster layer variables, as well as a line layer, and then we talk about this one. This one's pretty important. The M digitizing. That's kind of our flag when we've started creating the dam, and then we've got kind of a default zoom in cursor. So we start off with our form main function, and that runs the initialize component function, and then it basically loads in all of our references, especially the dot spatial references. Now this is the load button. When we click it, it basically removes all layers, and then it allows you to add a raster layer. The digitize button, when it's clicked, basically clears any digitized points, and it basically changes our M digitizing flag, the Boolean variable that we define, and then it also changes the text in our button. So when we are digitizing, it changes the text to draw dam, and it disables, or it basically gives the M digitizing Boolean variable a false value. Then otherwise, if we're not digitizing, then it changes our cursor, changes the text, and then it disables the load button. Now the reset button, when it's clicked, does basically exactly what you'd imagine it would do. It clears all points, removes layers, basically it disables the reset, load, and the reset button, and then the load button is enabled, and then the draw dam is the new text, and then it also clears labels, and then it clears our charts as well. Okay. Now when you actually click, now this is the mouse click in the main map, and that's kind of where the majority of the work is done. When you click, it basically gives now if you're digitizing, it allows you to collect the points as a pixel in the screen, and then we convert the pixel to a projection, and then later on here we're able to convert the projection to a cell. So we're actually able to call out different cells in the raster itself. Let's see here. Now this is where we actually get a handle on the DAMCalc class, which Hermano is going to talk about. So we've got a few functions that we're going to call. The getDam function basically allows us to calculate the getDam and getResults allows us to calculate the area and the volume, and then we add it to the labels. And then it allows us to chart our HA curve and profile curves, which is what we do there. Now we actually get a handle on the image we create, and we save it as the temp TIFF. These lines of code right here allow us to actually visualize the line, that red line. As we click on our first button, we see a red line, and that's we've defined the width and the color in these labels, or in those lines of code. And then the paint event in the map main area allows that line basically to follow our cursor. And then obviously we have the save button, allows you to save it as a TIFF file, and then the help link links you to the help text file.
This is Herman again. I'm gonna go really fast through the object DAMCalc, is the actual algorithm. So this object is in the same namespace. We define a big bunch of internal variables that in an object are called properties, and then we have some functions. This one is the instantiator or whatever, the object creator, and receives all the parameters and puts them into this part. And then we have this one reads the raster and populates a matrix or an array. That is one where it actually runs the algorithm. This one is a way to trim when you try to get values that are out of the boundaries of the array. Well, you trim it to the borders. This one is the one that says which level we have, taking the 2 points of that define the dam. It gets lower to set the level of the water. This creates an empty map that we will use later. This gets for each cell the values of the surrounding cells. This is where the one that creates the dam. You saw in the other part of the code how we run it. It's actually a propagation algorithm that goes through the dam, through the DM, and tries to see which cells would belong to that lake. And well, this part does all the logic. This one reads the results in that array, in that matrix, and turns it into these other arrays that hold the information of the layout, the elevation of the layout, and also the HI curve. And this one creates an image with that array, so we could later import it as a new raster.